All right, day 3, here we are. Good for me. Okay, so we're solving absolute value equations. There's just some things slightly different than regular equations when we solve absolute value. And that is we typically will have 2 solutions and not just one solution. So when we look at the absolute value of x, the solution here is absolute value of x is equal to 5. It's not only 5, but it's also negative 5. That's what it means by having those 2 solutions. So we must isolate the absolute value first, then set it equal to the positive and negative solution. So our first example, the absolute value is already isolated. So we would take x plus 6 and set it equal to 4. And we'll also take x plus 6 and equal it to negative 4. And then just do our typical solving, right? Subtract 6, subtract 6. X is equal to negative 2. Subtract 6. X is equal to negative 10. So our solution set is negative 10, comma negative 2. And if you can't make those squiggles, last year they just wanted to write it like this. Okay? So either one of those works. So that one was easy because everything was isolated. Well, now we have one that isn't isolated. So what I mean by isolated is that there's nothing outside of those bars on the same side of the equal sign. So what I'm going to do here, 3 is being multiplied to this absolute value. No, you do not distribute into an absolute value. You have to take things away from it. So I'm going to divide by 3. So then I'm left with the absolute value of x minus 18 is equal to 15. Now we can do what we did in the last one. Just set the absolute value to the positive solution and the absolute value part to the negative solution and solve. Thirty-two, 33. So our solution set is 3, comma 33. All right, moving on. Now I have 2 things that I'm working up against to isolate, to get just the absolute value by itself. So everything needs to go away from this. So I first add or subtract away from it first. So I subtract 5. Negative 1. And I'd multiply both sides, right, by a negative 8. Because that's an 8 over 1, right? That cancels. So I have the absolute value of 2 minus x is equal to positive 8. And then we set equal to positive, set equal to negative, and solve. Gotta divide out that negative at the end. So our solution set, 10, comma, negative 6. So all of these problems will look pretty much identical to this. They're either already going to be isolated, or they're going to need to have something added or subtracted, or they're going to have something multiplied or divided, or both. Okay, so this is an example of both. This is an example of one operation that needs to be done to isolate, and this is already isolated. All right, so this last one here, looks like we have to divide out this negative 18. Negative 3, yeah. Okay, so now I have an absolute value is equal to a negative number. So off the bat, question mark or exclamation mark, exclamation mark. No absolute value can equal a negative. Because essentially, an absolute value is telling you the distance a number is away from 0. So distance is never really negative, essentially. Okay, so the answer to this would be no solution. Okay, so we saw 4 different types, and it's pretty simple, and we know that we're going to have either 1 or 2 solutions or no solution. There is a case, I guess I'll go ahead and just write that real fast. The case where there is 1 solution is if I were to have something like this. There's only 1 number that can be plugged into that to make it 0, right? So that's x minus 5 is equal to 0. X is equal to 5. Okay, so anytime an absolute value is set equal to 0, it's 1 solution. Okay, so I guess I put another case in there. So 1 solution, no solution, or most of the time it's 2 solutions.